Hello and welcome to the Daily Space for today, July 23rd, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Now, as any of you who were on our Discord this morning on the Benny Mappers channel heard, there's not a lot of news going on right now. We are in the height of the summer doldrums. We are in the aftermath of the Apollo 50 anniversary. I think it's actually still going on. I suspect it will still be going on until 1973 when all the Apollo missions are behind us. But I did find one story lurking in the archive, waiting for us to take a deep dive. So today's format is going to be a little bit different than normal. Instead of going through a bunch of highlights from a variety of different news stories, well, since there weren't any news stories, I'm instead going to talk to you about one article that I tracked down. Now, this one article has to do with the ALMA images that we have been looking at, for the past couple of years that show us gaps in the disks of forming solar systems. Now, what we have been... Okay, I'm being asked for more gain, please. Sorry about the audio. I forgot to move my mic closer to my face. There we go. So one of the things that we've been talking about for the past several years is the Atacama Large Millimeter Array has been able to take images in millimeter light that is beyond what our eyeballs can see, and make out in the disks of warm gas and dust surrounding forming solar systems gaps that seem like they should be indicative of planets forming. Now, the reason that we made this supposition is twofold. First of all, our generic model for how solar systems form is that you have a cloud of gas and dust, a giant molecular cloud, and something happens that causes that cloud to begin to collapse and fragment. And each of these fragments, in turn, will begin to rotate. And during that rotational process, they flatten out, and you end up with a disk of material surrounding a central protostar. Over time, that protostar gets big enough that it becomes an actual honest-to-goodness star, and that disk of material surrounding that young star begins to grow gaps, and it's in those gaps that planets are actively forming and sucking in with gravity all of that material. Now, one of the things that we've been saying a lot is that if anyone tells you they understand the details of how planets form, they are lying. We have this big picture understanding, and it's played out across multiple types of images, across multiple different ages of star formation. We see the giant molecular clouds. We see fragmenting molecular clouds that are in the process of forming stars. We can see the cocoons, the stellar proplyds that are those young solar systems in the process. We can see the proplyds emerging from their cocoons to reveal that disk with the young star in the center. But we don't fully understand the details of how you go from blob of material with forming star to star with formed planets. And we see planets. We see 3,000 planets out there around a myriad of stars. And these planets don't tend to be in the places that in the 90s we would have said the planets should be. So a group of scientists, and here I'm going to share a link to the article with you in the chat. Here is the original article. These scientists have been struggling with are the observed gaps in protoplanetary disks caused by growing planets. This is a paper by Nelson Nagu, Bertram Beisch, and Edward Gurua. I probably mispronounced all of their names. for which I am immensely sorry. This science, what they did was they took these ALMA images and they used all the data they could find to figure out how old are each of these solar systems. And then they looked at the gaps, and they used computer models to figure out how much material did the disks need to form planets in the places that these gaps seem to be indicating there are planets. How big should those planets be? And based on that information, they look to see, can we spot those planets? And here is where things don't seem to match. Working at the Max Planck Institute in Heidelberg, they ran simulations, and they figured out that some of these disks would need 2,000 Earth masses worth of material to grow the planets that would be required to fill the gaps. And that doesn't work so well. And they figured out that the planets should be much more advanced in their formation than the ages of the stars seem to indicate. And here's the real kicker telling us there's something we fundamentally don't understand. While in some of these systems, and I mean a very tiny number of the systems, we have actually been able to directly image planets. This is where telescopes like the Hubble Space Telescope, the Very Large Telescope in Chile, they come into play, allowing us to expand our data from the millimeter to the infrared, allowing us to look for those worlds that are reflecting starlight and radiating away their own early formation-related heat. And yes, in some systems, a tiny, tiny number, we're talking tens, not the hundreds. In fact, we're talking less than 10, I think. We see planets in those gaps. But in more of the systems, we see gaps that would require there to be an advanced Uranus or Neptune-sized world, or bigger. And we don't see those planets. Now, this gets us at the second reason we were expecting all of these gaps to have planets. And this is because when we look at Saturn, which is the best ring system we can see, because Cassini, from Cassini data, we know that the gaps in the rings, in Saturn's rings, are in general caused by shepherd moons that are basically, well, creating the gaps, basically shepherding all of the material in the rings to stay out of the gaps. And it's the gravity of having those moons in the gaps that allows those gaps to persist. If those moons got ejected, if those moons got, well, destroyed, those gaps would fill in. And when we see gaps, we know there's a moon that we need to find, or moons that we need to find. So knowing that physics works the same across many different systems, many different scale sizes, it was assumed that when we're looking at these disks around stars, the physics, the kinematics, the fluid dynamics, and dust and rocks tends to act like a fluid at these scales, would all follow the same model as Saturn. The thing is, what we're seeing with ALMA, when you look for the planets, they're not always there. When you look for the age of the system based on the star, you're seeing gaps that don't match the age of the star. So this tells us that either we totally don't understand the time scales at which things happen, we totally don't understand what size objects are required to create different sized gaps, or, and here's where Occam's razor comes in, and the simplest solution is often the one that proves true, we don't understand gaps. And this is where you can start imagining, well, maybe some of these rings are caused by different resonant patterns in the material, where maybe there's something out there at a different distance that is driving these gaps. We don't know. And maybe there's just something that allows these gaps to just happen, and we don't know. And this is awesome. I've talked about this before. When scientists are talking with people, there's this accusation of, well, scientists just think they know everything. Well, no. Scientists actually are acutely aware that we don't know everything. And this is why we science. It's so we can, well, mind the gaps in our intellectual understanding and try and fill them in through work that takes generations of scientists building on each other's ideas to figure out, well, how do solar systems form? To figure out, how does the sun last for so long? That one was a real perplexer because we didn't understand quantum mechanics until the last 100 years or so. So when we see systems like this that make no sense, it tells us there are things we don't understand worth pursuing. And when we build telescopes like ALMA, it's often justified by saying, we're going to solve problem X, Y, and Z building this telescope. The Hubble Space Telescope was justified by two major things: to measure the Hubble constant, which it didn't really succeed at doing, but it's still working on it, but also to figure out what the heck planetary nebula are and how they have such weird structures. And we're still working on that, but we're a whole lot closer than we were prior to Hubble, when planetary nebula were just weird fuzzy things that came in all sorts of shapes. With Hubble, though, we revealed all sorts of questions we didn't even know we needed to ask. And with ALMA, it had its own justifications. But the thing that is making ALMA so amazing is it is raising questions about planetary formation that we didn't even know we needed to ask. And so when I look at these things, it makes me bitter that we don't have the James Webb Space Telescope yet, because it might be able to probe for smaller planets. It might be able to help answer the question about what's in those gaps. But this telescope is justifying its existence by raising questions we didn't know to ask. And kudos to the science team whose names I'm going to slaughter once and again, working at the Max Planck Institute: Nelson Nagu, Bertram Beisch, Edward Juro. Thank you for taking the time to say, hey, let's think about, we're seeing all these gaps, but we're not seeing planets in all of them. Does this make sense? Because I know I was willingly allowing myself to go along with the pack and say, why, yes, a gap means a planet. And they're right. The gaps may not mean planets. And that's awesome. Okay, so that's all the science I have for today, because it's a really slow news day. But I will now answer your questions, and I'm going to remind you all that you can do science too. You can help us out by going to bennu.cosmoquest.org and helping us map out this stupidly rocky world so that we can find a safe enough place to land our spaceship, to grab some soil, to bring back to Earth. It's really more of a grab and go than a landing, but help us find the place. So ask your questions, please, at CosmoQuestX. And while you're typing them in, I'm going to remind you, this is a production of the Planetary Science Institute, working in collaboration with Youngstown State University. I am your host, Dr. Pamela Gay, but I am not the only host of this channel. We also have Annie Wilson, who will be here tomorrow, bringing you her weekly update on all things spacecraft related, because really, she's the one who keeps track of that stuff way better than I do. And we are brought to you by you. We are here thanks to your bits, your subs, your donations, your patronage at patreon.com/CosmoQuestX. Thank you for giving, that we can be here. And I'm proud to say that we're able to pay Annie a living wage. And that's because of you. So thank you. Okay. Annie is going to be here later today when the Planetary Society live streams the unfurling of the Light Sail 2, Light Sail. So join us later today. And this is a reminder, we come to you Mondays through Fridays, most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time with Daily Space. Sundays, Annie is back with the Sunday Science Hour. And we're also here randomly as, the science happens, the spacecraft's launched, land, and, a little bit of everything in between. So give us a follow. Follows are free right here on twitch.tv, and find out when we're going live. Okay, I'm going to scroll back and see what all I have to thank you for. And I'd like to start by saying the weather sucks everywhere, apparently. This was the discussion we were having at the beginning of the stream. People, where it's way too hot, stay inside and map Bennu. Stay inside and map Bennu. Let's see what else is going on. Thank you, Sammy Jap, for the tier 1 sub 3 months in a row. That is awesome. Thank you, Sammy. Larry Weird is asking, have you heard about dark matter stars that seeded gigasol black hole that fueled quasar? No. Dark matter shouldn't be able to form a star. It doesn't interact that way. So thank you for the bits, Keeper of Maps. Thank you. So the best and most reasonable papers I've read so far for how you get supermassive black holes in the centers of galaxies is you have a turbulent inflow of material while the galaxy is in the process of forming, and that turbulent inflow is able to allow the normal slowdown that you get from conservation of angular momentum to be overcome. If you have a link, I'd be interested in seeing a link. So let's see, what else? Hanny asks, could the timescales have to do with the composition of the cloud material? Don't know. These are all the things that we're going to have to look at. It would have probably more to do not so much with the composition of the stuff as the how big is the dust molecules. So the clumpiness of the stuff. Let's see what else. So Sammy asks, can a disk of material form planets before the star starts up? As far as we know, the entire thing is forming on a singular time scale that is dictated by the total mass going into the collapse. So if you have a massive central star, you're going to have a shorter time scale for the star's formation. If you have a tiny star, you're going to have a longer time scale for the formation. And planets form based on the mass of the system. But we could be completely wrong. More work is known. More work is known. We do know big stars form faster than small stars. We can see that when we look at forming star clusters. Yeah. Thank you, Arnstro, for complimenting my turn of phrase. I was quite proud of myself. else we have for questions? So Hanny makes the comment, science has great job security. Every answer leads to more questions. I wish that meant job security. The reality is that a lot of times funders who aren't scientists, so here I'm talking about like Congress critters and stuff, look at scientists who are like, we shall prove foo. And then the scientists are like, oh, we looked at foo. It turned out foo was more complicated. We need more money and more time. And the funders are like, no, you screwed up. So it's a double-edged sword. Thank you for the bits, Trekker Kev. Thank you. Looking to see if there's any more questions. So Light Sail 2 is going to be 2:20 Eastern. Light Sail 2 is 1 hour from now. 1 hour from now. Oh, Annie's cat is very old and very loud. Thank you for the bits, Bill Nash. Thank you. And can I get a shout out for Bill Nash? He's another one of the streamers here on Twitch. And he does a lot of photography streams. And it's just like brain candy. It's prettiness. Prettiness, and you learn how to make your own photos prettier. So check him out. He streams a lot of times in the evenings. Yeah, orange star. You can get smaller bodies before the central star has finished forming, but ALMA allows us to see stuff like that, and there's like a whole timeline that we thought we understood for when things form, and it's just still not working. The time scales don't work. They're mean. Hey, Michael. So Michael's suggesting make ALMA bigger to increase the resolution. I think we call that the square kilometer array, and they're working on it. Yeah. It would be awesome to see what's in the gaps. I'm good with your no questions, just bits. I hope you learned, though. You don't have to have questions. You just have to have learning. It hurts your brain, Larry. I'm so sorry. I don't mean to hurt your brain. I mean to fill your brain. Oh, status check on the deployed sail is approximately 2 hours later. So 1 hour from now, we're going to have the sail deploying. So expect the stream to go for a while. I suspect there will be rage mapping of Bennu involved. So I see people commenting on bits for dogs usually leads to Cheerios. There are 3 dogs in here. The camera can't get them all at once. So there's Stella, Eddie, Malachi. I guess that's the best I can do to get all 3 at once. And they're all happily asleep, and I don't have Cheerios, so I'm being a bad dog owner, and you can't see them. There, let's transition. Now you can see doggos, or you can see parts of doggos at least. So we have Malachi, Eddie, Stella, and they're nicely asleep. So we're gonna let the sleeping dogs lie. So Michael is asking, is the square kilometer array the same wavelengths as ALMA? I don't think it's the exact same wavelengths, but I think that it brackets it maybe. I'll have to look that up. It has higher resolution, and the wavelengths that it's looking at will allow it to see the dust disks. It just sees them in a slightly different way. I'm glad you're bridging the gaps in your mind, DPA 209. There will be rage mapping. That's the only way to map Bennu, is to rage map it while cursing rocks. I like the way DPI puts it out. Let it out. Embrace it. Come to the dark side. We have cookies. Yes. Okay. So I think I've made it through everything. Which means it is time for me to go get lunch. And then I'm going to spend the afternoon pretty much at my keyboard. So I will be in the chat for Annie's stream. I have a telecon in 2.5 hours, so that should be after the stream. But otherwise, I'm going to be working on coding and grant budgets. And coding and grant budgets, probably alternating because I like myself. So I'll be around all day, and I hope to see you over on the CosmoQuest Discord. And before I go, I'm going to say I'm going to raid Oh Bother, and somewhere on my screen I have the ability to roll the credits, I think. There's always a question about that. I also am going to spend part of today trying to figure out why the credits don't always roll on this computer. So we will be back in roughly 1 hour's time with Annie as your host, and we're going to be sharing the experience of the Planetary Society rolling out the Light Sail 2 experiment. This is a new form of propulsion that is being tested that will allow us to not worry about having to carry our own fuel, because it's the sunlight that does all the pushing. So here is to hoping that works, unlike the credits, which won't work. So I'm just going to do the credits out loud, because sometimes that is necessary. Thank you for the bits from Bill Nash, Keeper of Maps, Trekker Kev. Thank you for the sub from Sammy Dijab. And thank you all just for being here. So, without further ado, well, with some further ado, because there's always further ado and rambling when it comes to figuring out where I hid things on my screen, we are going to raid Oh Bother, who is a maker, who will be working on something. Don't know what yet. I'm going to try to raid Oh Bother. Okay, it says that we have a raid in progress. So wherever you are in the world, have a fabulous morning, evening, afternoon, and remember to go outside and look up. It's one sky we all share. And I'll see you all on the other side. Bye-bye.